Hello everybody, and welcome to this week's episode of Google Maps Developers Live. I'm Paul Saxman, and with me this week is
Mano Marks.
And today we're going to talk about importing, modifying, and exporting data from Google Maps. The idea is that data comes in a lot of different formats. What's an easy way the easiest way, I think, to get the data into Google Maps? Modify that data because sometimes data doesn't look quite right, and there's some really simple tricks for actually modifying data within a Google Map, and then exporting the data so that you can re-import it for later use. Mano, on the other hand, is going to talk about something similar, but
I'm going to revisit a demo that I did this fall, which is parsing a shapefile, which is a geographic information systems format, directly in the browser. So we're going to get into a little bit of HTML5 and talk about the nitty-gritties of DataView and byte-by-byte access.
Right. So I'm going to be Mr. Basic, and you're going to be Mr. Advanced. So the approach I took was actually just the bare minimum. So what I wanted to do was to see if I had a file in kind of the ideal format, how could I get that into the Google Map as quickly and easily as possible? Like I said, manipulate it if the data doesn't look quite right, and then export it out. And each of these steps, takes a few lines of code, which I'm going to start off and show you now. So what I started with is this visualization we did a few weeks ago. This is the CLI WOC ship data. I'm not too sure these polylines are too visible on your screen right now, but we have a number of polylines here rendered on this map. This one was, so just for a little more context, the CLI WOC database, it's, what is it, 25,000 ship voyages?
I don't remember how many. I know it's 275,000 data points.
Data points, yeah. So there's just a ton of data. We gave a couple of presentations, I think it was a few weeks ago, on this data set and these visualizations. So this is just kind of a continuation of that. So it's 250 plus thousand points, 25,000 or more voyages. So quite a bit of data. We're not showing it all on the screen right now. I had the slider in here to actually, this goes, I think, or a range of about 20 or 30, no, it's even more than that. I think about 50 actual voyages at a time. So you can see there's a very rich data set. There's a lot of data in here. But as I'm scrolling along, you can see things like the polylines actually intersecting or laying over the landmass, which is obviously not something you expect to see in a ship database. So if you recall, by the way, so the two episodes, I think they're about 3 weeks ago that we did these, or 4 weeks ago. You can go back and see kind of how we built these visualizations. We talk about kind of the techniques we used and go through the code for actually building these. But this one we showed previously as well. This actually is all the data on the one map at a single time. And what I did is actually I put mouse event listeners on here. So as I mouse over these, I can actually see I'm actually changing the opacity, width, and opacity and width of the polyline dynamically as we're doing mouse over events. And you can see here, like if I highlight some of these guys here, we have some kind of crazy messy polylines. I'm not too sure if this was actually in kind of the original processing step that we did to get the data out of the CLI WOC database into JSON, which I'm going to talk about in a little bit. But it's just worth using as kind of a sample case for kind of messy data. And so you can see this polyline here that I mouse over. This is orange is England. This was a ship to I believe it was Indonesia, and there's quite a few points that are kind of off the out of sequence, and which to me would mean actually just bad timestamps. So what I did for this week is, whoops, that's not mine, is I took, exact same data set, pretty much the exact same visualization, but I'm just doing one line at a time. I actually kind of made them a little bit wider so that we can actually a little more easily get the mouse over event. And now the slider actually just goes one voyage at a time. So you can see here as I slide from left to right, I'm just going voyage by voyage. The little number on the top left there, which is 1493 right now, that's just the identifier from the original data set. And these are actually ordered chronologically, I believe. So So what I did, though, with this visualization, so this is kind of fun just to kind of look at the data. Ooh, we found a messy one there. That actually just looks like an inverted lat long. So what I did with this one is the mouse event, what happens now is actually I'm making the polyline editable. And this is actually a feature of the Google Maps API. So the polyline has a set editable, get editable, mutator and accessor method on it. And I think it's also a property in the polyline options. So you can make it editable by default. But this time what I did is just as I mouse click, I switched the polyline to editable. Then what I can do is I have listeners on these markers here, or these controls on the polyline. So if I click one of these, actually what all I'm going to do is delete it. So you can see now my data looks nice and clean. The other thing that you can do with these, and this is kind of a little more advanced, and I didn't really cover this in the code, but these are actually, so you can see here that there's two shades of markers or controls on these polylines. The dark ones are actually ones that are part of your original data set, and the light ones are virtual ones. So if I grab one of these and drag it, it'll actually create a new point in the path, in the polyline path. So the ones that are fully opaque, I can drag those around, and you get a little undo. And the ones that are slightly transparent, if I grab one of those and drag it, it becomes a real node. And also, once again, you get the little undo. And you can only undo once. But so again, this is all kind of default functionality or basic functionality of the Maps API. I can show you a little bit of the code how I do this. So let's get Sublime Text a little bigger. So and then I'll go back and show you some of the techniques that I use for loading the data in.
Can you bump the font up a bit?
Absolutely. How's that? So so this is the Polylines 3, the last one that I just showed you here. And so first I'm going to show you actually the event handling that I did for making it editable, and you'll be amazed at kind of how simple it is. So here, so this is I have a method in here called create polyline. This just allows me to do a closure around attaching events to the polyline when I create it, instead of just creating it in a loop, and which makes it a lot harder to attach events. So what I'm doing here is I just have a listener, a click event listener on the polyline. So here I'm checking if the event.vertex is not undefined. So this is, I'm basically saying, have I clicked on a vertex on the polyline? And if not, I'm just going to make the polyline editable. So this is saying, so the vertex event only occurs if you're already in the editable mode. If you're not in the editable mode, I'm just going to make the polyline editable. So you click the polyline. If it's not in editable mode, it's going to become editable. Otherwise, if it already is editable and you click on a vertex, then I'm going to execute this code in this statement here. And so here what I'm doing is I'm just taking the line, getting the path, and removing the vertex at that particular index. So that's actually taking it out of the path for the array, or for the polyline. And then here I'm actually going back to my original data set and taking that vertex out of the original data set. And this is pretty easy. All I did earlier when I loaded the code is I assigned an index. So this is going from polyline back to my original data set index. And so getting that out, and I'm deleting the voyage, or deleting the element from the array. This is a little bit of a tricky statement, just because when you delete a item out of an array, it becomes undefined. But it doesn't matter in our case, because everything works out the way we expect. And I'll explain that in just a minute. So another thing that I put in this visualization here, so we can edit it. So of course, once you've edited the data, you want to get it back out so that you can actually use it later. Put this little button way up at the top. It's a little bit small. Let's see if I can zoom in. There we go. And click that guy here. It opens up a new window. It sits here for a little bit because I'm actually doing document.write for the entire data set. And you can see here we have the data back out again. Oops, there we go. Make it a little bit bigger. So so you can see this might look a little bit familiar. It's actually just a JSON format. So that's the trick for actually importing and exporting, and I'll show you that now. So importing the code, even easier. So exporting is in JSON, but importing is actually a little bit easier, actually. All I did for importing, and I said I'm going to do the very basics here today, is, no, I don't want that guy here. The whole data set actually takes quite a long time to load, into Sublime. But so basically, I just formatted my data kind of in this format here to load it up, or to load it into my map. So basically, I just have the path objects, and each of those, so the ID, which I mentioned earlier, is the ID from the original data set. The country is which I use for coloring, and then the entire path. So the path is what I use for actually generating the polylines. So this is actually a JavaScript script, not a JavaScript JSON object or JSON file. So the benefit of using a script instead of JSON for loading files is I can just add the script tag, and it'll actually just assign this to my global context for my application. If you're using JSON, what you have to do is you have to put the JSON in a file. You have to do an XHR request to load the data. Then you actually have to send the data to the JSON parser to actually to get in your visualization. So the benefit of this is that you don't need to do all the extra coding to actually get the data into your map. The negative side is this really isn't portable. So this data is really specific to my application. Other people can actually load the data, but the catch is that this variable may already be assigned within the global scope for their application. So if somebody wants to use this data, they'd have to say, well, I have to make sure that, I'm assigning this. Actually, I think in my data set I use data equals, data is the variable name, which is probably the least generic version, or the most, anyways, probably the worst naming convention I could use for portability. But for my visualization, it was for my personal use, it was pretty straightforward to use. You can see here all I'm doing is just including a script tag, loading that file, and then all that data is available to my application. So it's really just getting the data in JSON or actually JavaScript notation and loading the script. I do have to go through a little bit of manipulation because those lat longs in the original file, I actually have to convert those to Google Maps lat longs. I could actually put this in the original source file because it is JavaScript. It'll just run when I actually load that script tag. But I like to kind of keep the data a little easier to read instead of using these Google Map lat longs. It also makes it a little more generic, even though ultimately it's not at all generic. And anyway, so creating the polylines by loading those lat longs into these polylines, and that's pretty much it. Exporting the data, since this actually turns out to be a couple lines of code, which is really nice. All I'm doing is I'm just JSON.stringifying that original data object. So I'm loading the data file or the data variable or the array of objects in, and I'm doing the manipulation using the polyline, but then actually removing the data from the original data set. And then when I want to export, all I do is JSON.stringify and write that to a new window. So just a couple lines of code to export, a few lines of code to import, and getting into a map is pretty minimal code, I think. There's a lot of limitations with this approach, namely, like I said earlier, with these polylines, you can actually manipulate them. So instead of just deleting nodes, I can actually drag nodes around. So this code that I have here actually doesn't support that because all I did was, all I'm listening for is click events on these vertices. If I did want to support that, I'd have to do a couple of different things. Either I'd have to, instead of serializing the original data set, I'd have to actually serialize this path to JSON. And that's a little bit tricky because this is a Google Maps lat long object. If I just JSON.stringify that, it's going to look like a Google Maps lat long object, which is undefined, which is in a public interface, actually. So the other approach is I can actually just manually stringify this. Or what I could do is, I could set up a kind of more event listeners because I do have like mouse up, mouse down, and mouse move events for polylines. I could listen for those, and then every time you move a node, go and update it in the original data set. Every time I add a node, insert one to the original data set. It's a little bit more work. I'd probably, just for fun, probably code it out both ways because, I doubt it's going to be like, we're probably talking about tens of lines of codes for both approach. But yeah, so maybe a future show.
Right.
And with that, so going to hand off. Mano has a really kind of some advanced techniques to show off. I was going to originally say like minimalist versus, I don't know, whatever the opposite of minimalist is, but it's not really that. I mean, because you're really showing not all data is JavaScript format, right? I mean,
right.
A lot of data is.
Do we have mine?
Oops, you're going to have to load it. I'm sorry.
That's fine.
So while Mano's loading the file, so what he's done is he has Esri Shapefiles, or I think Shapefiles are kind of a generic format now. There you go.
Okay.
And so lots of data, lots of GIS data and maps data is actually in this file format, and so things like the natural Earth data we've seen before, with some of our visualizations.
Right. So a lot of authoritative data ends up being in shapefile format. Data that's given out by government agencies, particularly resource extraction companies. A lot of places like using the shapefile as an interchange format. And one reason is because while it's owned by Esri as a company, they have opened the specification. And it's actually kind of interesting. A shapefile is technically not just a shapefile. Where would I?
To the here. And then
okay.
Sorry.
It's multiple files.
I'm gonna chase it down. So and then
okay, there we go. So I'm gonna shapefiles are generally distributed as zip files, and they'll have a bunch of different files in there. There's the SHP file, which is where it gets its name, and that describes the geometry. There's the DBF file, which is the database file. It's in an old XBase format. Basically, think DBase 4. So we're going back to the early 90s at this point. Actually, one of my first data management jobs was working with DBase 4 for DOS quite a while ago. But this format, and by the way, if you're ever going to write a DBF parser, don't make the mistake that I made, which is looking for the latest DBase specification, because apparently DBase went up to DBase 7. The XBase parser that most of the DBF files that you'll find out there is basically DBase 4. And there was quite a bit of difference. So I lost a few hours trying to track down bytes in that way. There's a number of other files in here. There's a PRJ file, which tells you what the projection is. We're not going to worry about that one today. We're just going to assume, and because I know this particular file is in WGS 84, so it's standard lat long. And then there's an index file. There's a number of different files that can be associated with this. For our purposes today, we just need SHP and DBF. So this is my standard HTML. I've actually separated out entirely my JavaScript code from the HTML file. Then I have SHP load sample.js, which does the basic loading of the map and calling out the SHP and DBF parser files. So I'm gonna and then giving them some callbacks to what to do with the data once it gets it. So let me just take a look at the sample just so you can orient here. I actually downloaded from the U.S. Census census tract data for California. I think it's a 26 megabyte download, so that's zipped. together. That's quite a bit of data being loaded, and it does take a little bit to load. I'm not going to show you that here, but you can see here there are a whole bunch of different polygons within the state of California. And you see if I click on a polygon, I actually get an info window, and I get the same data here along in a side panel. So, and if I click here, it just resets the info window and the side panel.
So this is kind of just one example of the kind of data you can get, though, out of like Shapefiles, right? I mean,
right. We work with polygon data, country border data. There's point data, polygon data, line data. There's a whole bunch of different formats that you can get your data in, and you could spend quite a bit of time delving into shapefiles. Shapefiles are probably the third most common data format that's available on the web. The most common by far is KML files, which there's over 1 billion of. Then there's GeoJSON, which is in the numbers in the millions, and then there's hundreds of thousands of shapefiles. But as I said, they're often authoritative data. So let's just take a quick look. I'm using for the SHP file, I'm using a file called shp.js done by Amari Heikkinen, who's an ex-Googler, used to work on the Chrome team. And he was just interested in some geometry. So he released shp.js and then modified it to remove the 3.js portion that he used, because I don't use that for rendering here. So just to make it very simple, and then I created on my own this dbf.js, which mirrors that file, but parses out the dbf file, the database file. So just quickly walk through how SHP.js works. We have this SHPParser, which allows you to do loading here. So SHPParser.load, and it takes a URL to a file, a callback, and an error function. And so the URL is the file that it'll load. The callback is the function that it will run once you've completed loading, and the error is what happens if something. What do you do if it doesn't actually work out? So we create a new XML HTTP request, XHR, and we give it a response type of array buffer. Now this is new in HTML5. Modern browsers support this. Older browsers don't. This is allowing you to parse data as a binary.
Which is always kind of a little bit of a misnomer, right? Because it's an XML HTTP request and you're loading binary.
Yes, it's that's something that is a little odd. The XML HTTP request was something put in to parse XML data back when that was how a lot of data got into browsers. But it is, as you mentioned, you can load JSON data in it, you can load CSV data, you can load a lot of different formats in.
It's basically the tool you want to use for loading data across the HTTP.
Right. Now, of course, you can also only load from the same domain, because that's a security feature built into XML HTTP request, and prevents you from doing something like damaging to a user's browser by loading in potentially malicious code from somebody else's domain. No surprises to the user. That's the no bad surprises. And then we create this variable d, which is the data, by running the parse function. And I'm going to walk you through a few steps here just to give you a sense of how this works. But you can see here the parser.parse takes this function, takes this array buffer, creates an object, and also creates a DataView. And DataView is, again, new in HTML5. It's modern browsers. It gives you methods to access the data within a binary array buffer. and then creates this IDX, which is a variable which is just an index, just to say, this is the index, this is the byte that I'm at this moment. And then the first thing it does is it checks, it gets a get in 32 on the DataView, which means it's parsing basically the first 4 bytes. And it's saying, it's just checking to see that it's got the correct file code, because SHP files, those first 4 bytes always equal this value here. And then it just walks through all these different bytes, basically creating attributes for the object. Here we've got word length, and then byte length, and then the version number, the shape type, and then each time it advances the index by a certain amount in order to get the next set of bytes. So here you can see it's get it in 32, get float 64. It's just walking through to get these values for you. And then at some point here, after a certain number of bytes, we actually look at the record. So much of this is actually the header. Floater, the header for the file. So you see it's giving you min x and min y, max x and max y. These are values that describe the bounding box, basically, which you're operating in. And then each records you are parsing through to get. You've got a record number, you've got a record length, and then parsing out the shape, which just defines the well, here we have a whole parse shape function, but basically parsing out the x and y coordinates, and if there's any other coordinates, the different coordinates there as well. So other coordinates would be things like altitude. And you can see it gets quite involved, and it's really one of the things you discover when you're doing this is it's really very detail oriented. You're going in deep on, okay, at byte number 4 I get this value and it means this thing. It's a very sort of like deep parsing kind of thing. And if you miss one byte, everything looks really wrong, and you get confused. You miss the flag that tells you that you've ended that your search for a particular field. But it's worth it when you get to the end and you're like, wow, I just did something really cool. I parsed a binary file in JavaScript. It's pretty awesome. So the DBF that I wrote, and by the way, the SHP.js is on GitHub. DBF.js we're going to release in Google Code at some point. It's in code review right now. So hopefully you'll be seeing that fairly soon. But I just follow that same format when I'm walking through here. And I actually parse out a whole bunch of data that you probably don't even need. Like there's an encryption flag that tells you whether it's encrypted. There's an incomplete transaction flag that tells you whether or not the DBF file was saved at some point in an incomplete state. When you get that in a production file, you're probably not worried about this. But and then once I've got that, so for the shape.js, once I have parsed through that, I have the callback is this ShapeLoad, which basically I create a polygon for each polygon in this data set. So you see in here, I actually check what is the type of the shapefile, and assign the different types to the object. But then I go through and I pull out basically all the points and create an MVC array for each path within each shape. So this is, let me go back to the result here. You'll see that there are a bunch of polygons, and some of these polygons actually have what are known as inner polygons their inner rings. That is when you have a polygon that has a hole in it, and Maps API supports that. You can set multiple paths, and if a path is within a polygon, that will show up as a hole in your polygon. And
then call those donuts.
Yes, they're like donuts. Exactly. So yeah, so it's pretty much what I've done. I'm going to actually take a look in the JavaScript console because I have it log both of the objects, and I'm not sure if this is going to be visible here very well, but let's open that up a little bit. This is the SHP file, and you can see each record contains an array of objects that has a shape in it. It's quite, you have to SHP, it's the record 0 has a shape, has a content, and you see it's got a max X and a max Y in it. Yeah, that's, just pulled that off screen. Which defines the boundaries of the shape. But then it's got a whole bunch of points. And one of the interesting things about this is shape.js has longitude and then latitude. So that's the point order. So you have to be aware of that when you're creating your lat-long objects. You have to flip them around.
Oh, so it's long lat a shapefile.
Exactly.
Lat long. Oh,
much like KML files are actually the same way.
It's a very practical tip.
Yeah. So then in the DBF, we have the same sort of thing. We have the number of fields, which we parsed out from the file, and then what those actual fields are. So here you can see the values. And they're parallel arrays. So in the records in the DBF file match the records in the SHP file at the same index. So the first record is the same as the first record. The second record is the same as the second.
So how hard would it be to kind of export this JavaScript version of your shapefile into let's say a JSON file or a JavaScript?
Very easy. I mean, you see right here, once you have the code, which Omari and I have written, these are objects, right? Mm-hmm. These are JSON objects. So you just stringify that and port it out. Then you could just use that without parsing the object again.
Right. Cool.
Yeah.
And so, I mean, it's when I saw this the first time, I was kind of amazed that, like, I mean, this is a massive number of polygons, right?
It is.
I mean, we're seeing like some pretty amazing performance, like polygon and polyline performance out of the Google Maps API.
Thousands of polygons, each of which has multiple vertices. Yeah.
Yeah, yeah. The ship data again, it's like 250-some thousand points. This has got to be. I'd assume this is actually beyond that even.
This is all rendered in Canvas on top of the Maps API, so you're seeing quite a bit of performance here. I mean, you can see how the different. These are just the census tracts for San Francisco here, right?
Right.
Yeah.
Yeah, so it's a really nice data set. I mean, and this is actually one of the probably the most popular use cases I've seen is, doing census data. I mean, everybody always wants the state boundaries and province boundaries. A lot of that data, like you said, like kind of the official data sources provide these shapefiles, which makes this a really powerful tool.
Yeah.
So
exactly.
Nice. So
cool.
Maybe in a few more weeks we can do some census data analysis.
Mm-hmm. Right. Yeah.
So
exactly. Cool.
Awesome. So that's pretty much it. So we have advanced techniques or basic techniques. Just like loading JavaScript objects. Making them editable in the browser, in the map, so that you can actually export them again. Kind of clean up your data or beautify your data. And then we see some advanced techniques using shapefiles to get the shapefiles into your map, and then as we mentioned before, you can just JSON.stringify and get that data back out again in a format, so you don't have to ever parse it again.
That's right.
So Although I assume some of this data might be licensed, but that's up for the user to investigate. So so if you guys have any questions, post them in the comments, please, and we'll try to get back to you. And we have this Mano's data is kind of in code review. Mine's getting ramped up for code review. So I know we've said this a few weeks ago before I was on vacation, but the code is on the way because we definitely want to get it in your guys' hands to see what you guys can do with it. So so enjoy, and we'll see you next week.
All right. Thanks a lot.